All right. So I'd like to thank everyone who's joining us today and welcome you to our today's CNCF webinar, Develop Your Cloud Native Use Cases at the Edge with K3s. My name is Michael Hausenblatt. I'm a developer advocate in the container service team at AWS and also a CNCF ambassador. And I'll be moderating today's webinar, helping out a little bit. And I'd like to welcome our presenters today, Pranay Bakri, as he's a staff technical marketing engineer at ARM, and Julio Suarez, he's a staff engineer at ARM. Before we start, a few housekeeping items. During the webinar, you're not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop your questions in there and get to that at the end. So this is an official webinar of the CNCF, and as such, it is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that code of conduct. Basically, please be respectful of all of your fellow participants and presenters. Please also do note that the recording and slides will be posted later today to the CNCF webinar page at cncf.io/webinars. And with that, without further ado, I'll hand over to Pranay and Julio to kick off today's session.
Thanks, Michael. Hi, everyone. My name is Pranay Bakri. I recently joined ARM as a technical marketing engineer in the infrastructure line of business. I'm responsible for building technical solutions around ARM's ecosystem of products. I work with our partners to develop joint collateral around cloud native technologies and DevOps methodologies. I have a co-presenter with me today, Julio. Julio, would you like to introduce yourself?
Sure. Thanks, Pranay. So hi, everyone. My name is Julio Suarez. I'm a staff engineer at ARM. My role is to basically work with partners, customers on solutions. So these solutions take on many forms. They can be working on a proof of concept with a partner, or contributing to an open source project, or just doing like presentations and demos like what I'm going to show soon. So I'll leave the introduction at that. Thanks. You can take it back, Pranay.
Thanks, Julio. So today, let's look at the agenda. Essentially, we are going to look at the evolution of Edge and the cloud native disruption, and Project Cassini, which is an ARM's platform for the Edge, that an initiative that we have. And we'll mainly be focusing on two demos for use cases at the Edge, such as what does CI/CD at the Edge looks like with K3s and Gitlab on ARM platforms. And we'll also look at a smart cities demo on how these integrations of physical devices with human interactions are driven by things such as ML at the Edge. The second demo is going to be covered by Julio, and the first one, we'll go through it. And in the end, we'll open it up for Q&A, and we'd love to hear your thoughts about it. So moving on. So first, let's take a look at a few fundamental shifts in the way computing, as we know, is changing. It's expanding and happening at multiple layers, from cloud to edge to endpoint, emphasizing the need for a strong infrastructure ready to take on more data processing than ever before that can serve 1 trillion endpoint devices in the near future. This is one reason we've seen ARM architecture on the rise in the last few years. So a very brief intro to who might not be familiar with ARM. ARM is a global leader in providing IP licensing to its semiconductor and other ecosystem partners. It's a reference as a reference to this growth. It took around the first 26 years to have around 100 billion ARM-based CPUs in the market. And now we are on way to the next 100 billion in just 4 years. So just to look at the momentum of how it's building, right? In recent years, we've also seen an explosion of demand for high performance, high efficiency compute that is available at scale. And this demand has skyrocketed with the move to the public cloud and with 5G networking everywhere, where compute nodes must operate within strict latency constraints and power budgets. And then we have edge and on-premise workloads that require on-device computing that is powerful enough to filter and react in real time. So with this change in data creation and consumption model, the sufficiency of a good general purpose compute is no longer feasible. So this requires heterogeneous compute that is tailored for network, storage, security, and AI/ML, etc. And we are seeing these in edge computing with form factors such as SmartNICs. For example, a SmartNIC is a network interface card that includes a general purpose CPU that offloads the processing done by server CPUs and reduces the additional overhead. So moving to, let's look at some of the specific challenges and requirements for edge computing today. So there are some definite set of challenges that we are seeing in edge computing. One of that would be latency and bandwidth requirements. So I think we all know that there are applications that are deployed at the edge that might be sensitive to latency and bandwidth requirements that are not fulfilled by the cloud side of things. Another one would be the resource constraints. So these small edge devices often do not have that huge compute capacities of their cloud counterparts. And these are not designed to be managed at scale in a resource constrained environment. Another important aspect of it is security. Security principles from data center do not necessarily apply as is for all edge scenarios. And also the device landscape is so fragmented that there is a growing need for standardization of security principles for the edge that's integrated between software and hardware. The another one would be data proximity to, there are edge deployments that are required to be close to the edge, to be able to make that intelligent data processing decisions close to the source, right? So in many cases, these mean providing AI and ML close to the data source to be able to keep up with the growing data that is being generated. And finally, but not the last one, is the scale. So the similarity, the scalability of these IoT components or the endpoints and how that influences the aggregation that needs to happen for these edge computing platforms is really important. So if we take a look at, apologies, keep going back. Okay. So in order to solve the challenges that we just talked about, right, and other requirements that are specific to the edge, what we are seeing is an evolution of the edge. So historically, the fixed functions that were performed outside of the data center included some sort of network function management. And from a software perspective, it was all about a single purpose, real-time operating system type environment. What's changing here is the stack is becoming more of an intelligent computing platform and ultimately leading to the emergence of what we are calling the AI edge, which can perform high-level functions to be able to make those timely decisions. And performing these intelligent functions at the edge has many benefits. It significantly reduces the backhaul to the cloud, cuts latency, and improves reliability, efficiency, and security, the most important one. And in a world where models may need to be evolved in real time, as insights from these global deployments, they come fast. So here's the reference of that AIH Stack that ARM has been driving with our ecosystem partners. This AIH Stack is powered by ARM Neoverse-based cloud-to-edge platforms, such as AWS Graviton processors in the cloud, and multiple devices, such as NVIDIA Jetson Nano, for example. Another interesting edge platform is HiveSilts, which are these rugged stackable platforms that draw power and connectivity as you stack them. So this stack is secured by ARM PSA what is called as platform security architecture, which offers a framework for securing these connected devices. And it provides a step-by-step guide in building in the right level of device security and reducing that risks around data reliability. And then we strongly believe that this stack is to be cloud native in nature, to be able to support the various functions listed out, right? For example, these AI or ML, data analytics, real-time filtering, networking services, and so on. Now, specifically for the edge, due to, I don't know what keeps going back. So specifically for the edge, due to resource-constrained platforms and also the lack of physical access that can make it difficult to mitigate any potential problems, the ease of portability, size, and efficiency makes containers as an ideal candidate to run these applications on these small platforms like edge gateways and edge servers that are typically located at the edge of a network. And because of these devices, the proximity of these devices, it's better suited to develop applications at the edge that provides low operational overhead and minimize latency issues and provide decentralized services. So to help this AI edge transition, ARM announced what is called as Project Cassini as an industry initiative, and it focuses on ensuring a cloud-native experience across a diverse and secure edge ecosystem. Now, Project Cassini consists of 3 pillars. Development of platform standards and reference systems. This is primarily led with ARM's hardware ecosystem. Security for the edge in terms of how ARM PSA extends for the edge. One of the projects we have submitted to CNCF Sandbox in this regard is Parsec, Platform Abstraction for Security. It's an open source initiative to provide a common API to hardware security and cryptographic services in a platform agnostic way. This abstraction layer keeps workloads decoupled from physical platform details, enabling cloud native delivery flows with the data center and at the edge. And the third pillar, or rather, sorry, I didn't talk about this. The third pillar is the cloud native software stack that can be deployed on these standardized and secure platforms. PSA framework is now extended to the infrastructure edge, and we have put together a good blog that on Project Cassini, and that I'll share at the end of the presentation. You can take a look at it. It's really cool. Okay, so moving on. So we come to our first demo of developing cloud native applications at the edge on ARM with Rancher K3s and Gitlab as CI/CD. So before moving to that and explaining what it is, we need to take a look at what are the, specific challenges and requirements we mentioned at the edge, and why we are doing CI/CD at the edge, and why it makes sense. So using CI/CD, as we know, it lessens the risk by supporting small and incremental changes to an application, and problems can be rapidly detected and mitigated before messing up with the production environments. And now when these updates are rolled gradually to a large number of these small distributed edge devices, any breaking changes can be detected and rolled back before they create a significant impact. So doing it at the edge, and again, as we all know, so containers are really lightweight platforms, right? So in a CI/CD system, dealing with the container images, these images are not updated after they're deployed, but instances of those images are destroyed and recreated. So in this system, these new images are generated anytime a change has been made to the application and deployed incrementally throughout the distributed environment. So in this demo, we'll see how Rancher K3s and Gitlab as a CI/CD platform can solve this problem. So a bit of an history about what K3s is. My apologies, the slide for some reason goes back. Kubernetes, as we all know, is becoming a key component when it comes to running and maintaining containers at the edge. And K3s is a lightweight production-grade open source Kubernetes distribution from Rancher. It has been designed for developers and operators who need to deploy applications quickly and reliably to the resource-constrained environments at the edge. It has a small footprint of around 40 megabytes, and it has been designed to run on these edge devices and the low memory constrained devices. And this actually have been achieved by removing a bunch of code from the upstream distribution. And it's also optimized for ARM architecture. About GitLab. So now that, so developing applications at the edge has a different perspective than traditional applications when it comes to code collaboration and deployment efforts. CI/CD at the edge, like we talked about before, provides risk mitigation to applications by supporting small and incremental changes and an eventual rollout of the application to the edge devices. And these issues in the code can be rapidly detected and mitigated without an operation overhead. GitLab is a web-based DevOps platform that provides a Git repository. And a major feature of it is, of course, the CI/CD part of it. And all these, the code and the scripts are hosted in this repo provided by GitLab. And they also support GitLab runners, so which is a build instance which is used to run the jobs and send results to GitLab. And these runners are supported on ARM64 platform. So we'll be seeing that in a bit. So this is the high-level architecture of our setup. We have the three major parts to it: build, deploy, and then changes to an application. We are hosting the GitLab, a self-hosted GitLab server in a GitLab on a Raspberry Pi. And then we are using the GitLab, ARM-based GitLab runners to build and deploy or deliver our application onto a K3s cluster that is running on top of Raspberry Pis. So everything is ARM-based and we are running this application on top of it. So the high-level workflow for this is going to be like when a developer commits code to the GitLab repo, and after the commit, a pipeline gets triggered, and the GitLab runner picks up the build job, it compiles the code, and then it creates a Docker image and pushes the changes to the registry. Now, in the next step, the image is pulled directly from the registry and deployed on the K3s cluster. So GitLab runner automatically, so we are going to see how we've connected the K3s cluster and then how the application gets deployed and a highly available application that we'll see in action. And whenever a new update is made to the application, that again is pushed as the new version of the application, and that application can sustain the new changes. So this brings up to the demo. So I'm going to switch to our demo slide or our demo environment. And we look at here is we are going to use a Go-based web application with its source code that's stored in this GitLab repository. We are hosting it as a self-hosted server, GitLab. And we'll also look at how the GitLab CI file looks like, what does the Docker file looks like, and what are the deployment specs for it. So if I go here and see, so this is our, it's a simple application. It just prints out some message, and this is how it's hosted here. So let me make it a bit bigger. And this is running on a K3s cluster. And this is the K3s cluster where it's running. And let me show the dashboard as well. Oh, it's pretty big. Okay, so you see that there are multiple instances or multiple pods of this application that are running over here. So when we look at this, so what we are going to do is we'll create a simple change here in this application, and we'll see how it triggers the application and the entire CI/CD pipeline, and then how it eventually gets deployed on the K3s cluster. So we commit these changes, and while that happens, so if we come back and see here, we'll see that a pipeline has already been triggered. So while that's running right now, we are going to look at these components and what they are. So if you look at, let's say, the Docker file. So if you look at the Docker file, we're using the ARM-based, Alpine-based Linux to build this application. So if this is a multi-stage Docker file build, and the reason for that is that for building it, we are using the entire Golang and with all the dependencies combined in it. But for actually the rollout of the application, we are using the minimum small Alpine Linux-based image, which is a very small image size, around 6 to 7 megabytes. So it's easier to deploy, and portability is also really efficient. And yeah, so this is our Docker file, how it looks like. We'll see our pipeline is also running. Let's see what's happening here. So yeah, so it's already triggered. There are 2 jobs, and we'll take a look at it in one go. But so coming back, this is how our CI file looks like. We are using a container image that is stored in a Docker registry. We are in the build stages. So we have 2 stages, build and deploy. Build is where our our container image for the application is going to get built and pushed to the registry. And then we'll come to the deploy stage in a bit. Before going there, let's look at how our pipeline is performing. And so we see here, it's already running the jobs. And while it happens, let's look at already a completed one that has completed over here. Let me show the build job real quick. So what it does essentially is it pulls the, as we saw in the Docker file, the Alpine-based image, and it automatically builds the container image over here. And let me make it a little bigger. Here, now, eventually when we are actually creating the build, we see here that it automatically does that from this builder, and then it tags and pushes that image to the repository. So once it does that, when we come back to the pipeline, we'll see that the build has already passed, and we'll see that automatically, yeah, so it did the same steps that we just saw. And if I look at here and I refresh it, we should see an image pushed a few seconds or moments ago. Come on. Right, so let's go here. Yeah, so this is a new one that just got pushed over here. And now let's look at how it's going to get deployed in the second part of our pipeline. So we see that the second part of the pipeline deploy section is already running. Let's look at what's going to go on in that particular section. We are going to connect to the K3s cluster, and we are going to set a bunch of credentials, and then eventually we are going to deploy our application. And with this, we also have what we are using over here is kubectl small image, because I want kubectl inside the container to run. And then we look at the deployment spec. So the deployment spec for this is a standard Kubernetes one. We're using 3 replica sets, and I'm also creating a service with the type node port, and I'm using the image that we have tagged and push to the registry, and it will be deployed in a sec. So if I come here and look at, look at our pipeline already got passed. So let's see what happened over in the deploy section of it. So if I come here and go to deploy, okay, so yeah, so what it did is it pulled the latest images from our repository, and it pushed the changes over here. So it did, we set the cluster context, and eventually we deploy this deployment spec that we just saw. And if I come here and see, so this is how it was looking right before. If I do this, so the changes automatically got published. So, and if I look at the Kubernetes dashboard, let me go down. So if you look at the pods, they were created like a minute ago. So right before when we push it, right? So we saw that, and these are the K3s clusters that are running ARM 64 bits. So I forgot to show you that in the beginning. So if you see here, these clusters are running on the ARM 64 version of it, and it's supported over there. So in this way, we saw that these small changes, so we just made a small change to the application. And if you take a look at the size of the image, it's pretty small, 6 megabytes. And we push that eventual application on the K3s running cluster. So with that, this concludes the first demo. And let me pass the ball to Julio, and he'll take us through the next demo for the session, and we'll see it in action. It's really cool. Julio, take it away, man.
Great. Thanks, Pranay. So
you can share your screen.
Yes. And sharing, should be sharing now. Can you give me a check, Pranay? Can you see it?
Works.
Yeah.
Okay,
works.
Great. Cool, thanks. Yeah, so I'm going to walk us through the smart cities demo now. And before I actually show the demo, I think it's a good idea to just paint the larger picture so that we can appreciate what's going on. So I'm going to start by introducing what's called the Smarter Project. This is a collaboration between ARM, AT&T, Oregon National Labs, the city of Chicago, a bunch of folks. It's a large list. But the point of the project is to basically make cities and towns smarter, right? All the places we live in smarter. And it's all for the purpose of improving the lives, right? The quality of life of the people that live in these places. So for example, in Chicago, what's happening right now is there are sensor arrays all around the city, measuring things like air pollution, pedestrian traffic, auto traffic, temperature, humidity, things like that. And the point is to use that data to, improve things like emissions and improve traffic and make things safer for citizens, right? Now, the way the project is set up is to develop a set of basically deployable reference designs on how to do this, right? How do you securely deploy, ML out to the edge? How do you manage those devices? That sort of thing. But, there's really two pieces here. Pranay mentioned it earlier, where, there's the management of that edge device, but there's also a lot of data, right? Because, for example, with the traditional model, right, data has always gone out, right? Think like streaming, you're always downloading, you're taking in data, but we're going to see this shift where a flood of data is coming back into the cloud. And so the second piece of this is to manage that data, right? How do you manage that data? Where do you process it? Do you process it in the edge? Maybe you need to process some of it in the 5G core network or the radio access network. And also maybe you need to just process it in the cloud and also store it, right? So it's kind of managing that continuum of data as well. So some use cases around this, for example, smart cities, which I'm going to show that. And like I said, there's this Oregon National Labs project in Chicago. And then other use cases are, for example, smart agriculture. So just as an example, Texas A&M they have this project where there's a 50-acre ranch and there's various wells scattered about, and kind of monitoring water levels and understanding how to best use this resource, this water resource. Another project would be the National Science Foundation SAGE project, where this is about putting out smart devices, smart sensor arrays out in the country, and to monitor climate change, or monitor, for example, moisture content, right, to prevent wildfires, and also predict how they might spread and things like that. So this is the sort of the overall smarter stack. There are numerous rectangles here. I'm not going to go through each one. There's really just two big pieces to understand here. So on the left-hand side, you have sort of the edge side of it, is managing that edge platform, firmware, secure boot, OS. How are you going to orchestrate VMs or containers, plugging in sensor arrays and things like that, right? So managing that edge device. And then on the right-hand side, you have sort of the data side, right? The data management side of it. It can be hosted in the cloud. You could also potentially host it in 5G core. And again, it's aggregate that data, process it, manage it, right? So it's two parts here. So now with respect to the demo I'm actually going to show, it's basically what's on the right-hand side. We took a K3s cluster, right? And the master node is on AWS. It's running, in this case, it's running on a M6G. That's an ARM instance. I went with that because it's very new, but it could be anything, of course. And then that's clustered with some edge nodes. Now, in this case, the edge is my living room. So in my living room, I have a NVIDIA Jetson Nano. I also have a Jetson NX and a Raspberry Pi. And on these individual platforms, I have a camera and a microphone attached to them. And the camera, there's an inference engine running for the camera, where it's basically just counting the number of people and cars that it just sees in its field of view. And then the microphone is capturing audio, and we're running another engine there that is categorizing the audio. So things like, am I hearing speech? Am I hearing music? Birds singing? Things like that. Of course, you can attach anything to it, but that's what we have here in the demo. And then, like I mentioned, there is this data side of it, right? So what I just talked about, right? That's those edge devices and managing how do you deploy things to them. But now we also have, in AWS, we have this sort of data cluster, data node, and that's gonna be the point of aggregation for data in this demo. And like I said, that's hosted on AWS, and what's happening is all these edge nodes are sending their data back up to AWS. And in this case, for this demo, it's just sending back the number of people that it sees, the number of cars that it sees, and also the audio classification. And on that data node, we're running FluentBit, InfluxDB, Elasticsearch, all sorts of tools, and Grafana as well for graphing. And now I'm going to switch over to actually show some of what we see here. So, for example, this is the camera in my living room. This one is actually running on this is the Jetson NX. I chose the NX just because I have a higher resolution camera on it. So it's just kind of clearer and nicer to see, but the Jetson Nano would show you the same thing, and the Raspberry Pi. Of course, the Raspberry Pi would be a bit slower, but it works. But anyway, so what you see here is I have a calendar of classic VW cars, and I just put that in front of the camera, and a toy, one of my daughter's toys. And you can see that there's a green rectangle around the car. It's basically highlighting that it's detected a car. And it's using the red one for the toy, which it's detected a person or maybe the form of a person, right? So again, this is the edge, my living room. And in the Jetson NX, the inference is running on the GPUs. It's all containerized, right? This is deployed with K3s. You're just applying YAMLs. And in the case of the Raspberry Pi, it's not running GPUs, just running right on the ARM CPUs. But again, it works. You can use any platform, right, for the edge part of this, as long as it can run K3s. It has a kernel that has been configured with all the maybe all the networking stuff you may need. Okay, now I'm switching over to the Grafana dashboard. So this part is on that data node. So this is on AWS, hosted on AWS. And it's aggregating the data from these edge nodes. So if you see on the top left, I'm looking at the Jetson NX right now. And in this first graph, we could just see the car count. You could see it's 1. And earlier in the day, it was 0 because the lights were off in my living room. And if I scroll down, I see the person count. It's similar situation, detected that toy as a person. Earlier it was 0 because, again, the lights are off in my living room. And then if I scroll down a bit more, I can see what the microphone is detecting in my living room. So over time, right? So there's a time series of different points. And so if we look towards the right, which is the most current, I can see that it detected a bird. I have a lot of birds that sing outside my front door. Speech, probably my kids talking. Some music. I think one of my kids was playing a video game earlier. But anyway, nonetheless, this is what it's doing, right? And this is getting aggregated from the edge, from my living room. And then at the bottom, this is just a table showing some probabilities. For example, it thinks it heard a turkey. Not sure what's that, but yeah. And that's basically it for the demo. I'm going to go ahead and pass it back to Pranay for just to kind of wrap it up and close up. Thanks.
Thanks, Julio. Okay, so sorry, I was answering a question online. Yes, so thanks, Julio, for presenting the Smart Race demo. It's really awesome. So this is the kind of the final slide that we have. And for any questions or any proof of concepts or any collaboration opportunities, you can contact us on this alias, project-cassini@arm.com. And there is just a bunch of reading material to the blog, a bunch of blogs on Rancher K3s. There is a white paper that we did with K3s and with ARM. The link to Project Cassini blog, as promised at the beginning, and the Smarter Stack that Julio just described. We have a blog out there for that as well. So anything that you want to understand or talk about, or any feedback, just let us know and we'll be here to help. So this concludes the presentation part of it. So
right. Cool, awesome. Thanks a lot, Pranay and Julio, for that great presentation and the demos there. We now have got some time for questions. I think we have a couple of them already queued up there. Keep them coming. Add them to the Q&A tab at the bottom of your screen. And yeah, we'll pick a few directly there and see how far we get, right? We still have some 20 minutes, so we should get through. First one up from Pablo Sinaga. How does the cluster decide where the application should run inside the cluster just using the node affinity? Who wants to take that one?
So is this in reference to the first demo, I believe? Yeah. So
I'm guessing so, yeah.
Yes. So K3s, it automatically schedules those jobs based on where the applications are hosted and or the nodes are lying, and it's really on the capability of that the K3s scheduler, and it automatically schedules those job on the nodes.
Cool. Thanks a lot. Abhinivesh Jain, thanks, Pranay. Can we run Smart City demo on Raspberry Pi as well?
I think I'll let Julio answer that one.
Yes.
Yeah. Yes, in fact, we've run it on Raspberry Pi. Earlier in the slides, there's actually a link to the GitLab link to the project, and actually there are even instructions in there about how to run it on a Raspberry Pi. So yeah, short answer is yes, it can run on a Raspberry Pi.
Yes. Perfect. The question is then just 4 gigs or 8 gigs. Next one up is John Sanabria. I hope. Oh, that's just a thanks. That was not a word question. Okay, that's also cool. Thank you. Michael Doherty, I appreciate this is variable, but would you expect scenarios where large amounts of data will be stored on the edge? Any examples, please? Guess that's again up for Julio.
Yeah, so would I expect scenarios where large amounts of data are stored at the edge? I'm not sure. Actually, what I will say is, if anyone that's out there that's listening, we are open to hearing out your use cases or your, what you might be thinking about at the edge. In this particular demo, we're seeing lots of processing at the edge, not so much storage, but yeah, I'm open to hear if anyone else can think of some scenario. I can't
this is
right now.
Bhumik. Julio, I can maybe
Sure.
help make a couple comments.
Okay.
So I mean, broadly speaking, there are lot of different use cases for the edge, right? So if you look at things like self-resilient retail sites. We've seen a lot of customers have increasingly more data stored locally because they want that self-resiliency at that location for various reasons. So that's probably one that comes to mind, which has the most like data storage. But as you look at some of the industrial IoT and other verticals where these gateways are doing more and more aggregation. So previously it used to be just filter and react and like process stuff and discard and send to the cloud, and it's still the case. But there's use cases where that aggregation itself is needs to be scaled, right? So in other words, the amount of devices is increasing, and then the data per device. So it's no longer just a filter and react. There's some requirements there that data needs to be stored there for more processing locally, right? So there could be, so it's not all real-time processing as well, right? So it's kind of in between real-time and storing in the cloud and doing it at your will. So there are use cases like that. I mean, retail is probably the big one, but then I think in like factory floors and other edge locations, even like government, like military outposts, where there are like a lot of rugged devices, but then there's like a small outpost. At that point, you could argue what type of edge that is, right? Because the devices become, the form factors are bigger, and there could be specific storage appliances. There's also like what we see, a lot of distributed storage appliances being used. So yeah, there could be use cases that enable those things.
Okay, cool. We've got more questions there. The next one up is from Luis Omori. Cool demo. Have you done any kind of scalability tests? For example, attaching thousands of working nodes. I think Kubernetes has a limit of 5,000 nodes.
Yeah.
Scalability.
Is this in reference to the smart city or the? I'm assuming it is, but.
Yeah, I think it is.
Okay. Well, I'll answer it. Yeah, in this particular demo, I personally have not. I've only run about three devices. Of course, I would, provided that you've provisioned, your data node and the cloud, basically the cloud side of it. Well, it should work, right? Of course, we need to test it further. I don't have that many devices on hand. Is really the limiting factor here. But it is K3s, and it is fairly scalable in the sense that, at least in this demo, the demo classifies device types like Jetson versus Raspberry Pi, and basically all these containers, like for image processing and audio and all that, they're basically deployed as daemon sets. So basically, when you join a node, it should just to kind of get set up and get all the containers, all this stuff deployed to it, and start just uploading its data back up to the cloud. So I guess my point is I would expect it to be scalable, but yeah, we would have to go in and actually test it, right? And get more devices.
Cool, thank you. I'm not entirely sure I can parse that from Andrayich. Argonne Array of Things is a city project in Chicago. Any other reference project in London, UK, or elsewhere?
So I'm personally not aware of others. I'd imagine there could be.
I'm definitely aware of a smarter city project, a new project throughout the EU. That depends on if you count London still part of the EU or not. But yeah. All right. Next one up is from Vanita Jayasuriya, I guess. Have you used DB on the Edge pod specifically for AI use cases? So I'm guessing it's about some kind of database or data store on the Edge pods.
I can just comment, not in this demo, but we're working with, for example, folks like Redis Edge, that has the Redis open source and AI gears, and then some time series specifically built for running it on the, doing analytics and database on the edge. So that's one example that we have worked with on the ARM platforms, which has the AI components along with the open source DB with Redis.
Cool. We still have time. If you have questions, keep it coming. All right. We have one more question from Shani Posin. Shouldn't the deployment use Helm? I'm not sure if it qualifies as a question, but
yeah, I think it's for the first one. Yes, you can. You can use a leverage Helm over there. You definitely can. I just didn't.
So to be more specific, right? I don't think it's supported with ARM yet. Using Helm to configure this GitLab CI/CD runners, but we are working with GitLab as a roadmap item to get that. Is that a fair response, Pranay?
Yeah.
Okay.
One point I'd like to add, though, I believe Helm 3 does work on ARM, though.
Yeah, no, it's to do with how you manage, how you deploy this using Kubernetes.
Oh, right. Okay.
Yeah. So it works on ARM, but how the Helm charts and everything else, it's not supported yet.
Cool. Any more questions? This is your chance. The Edge ARM. All right, going once, going twice. All right, okay, I guess that's it then. Okay, thanks again. That was really great. I think we learned a lot. And as a reminder, the slides and everything will be available later on CNCF.io /webinars. And yeah, thanks again, Pranay and Julio. That was it. And I hope we see each other at the future webinar, right? Have a great day. Cheers. Thanks.
Thanks, Michael. Thanks, everyone, for joining.